Good morning, all of you. This is Dr. Nageswara Rao, Assistant Professor of Physics, SRR and CVR Government Degree College, Autonomous Vijayawada. Today, we will discuss one of the combinational logic gate or NOR gate. We know combinational logic gates is nothing but the output of the gate is depending on the input of gates at that time only. It is nothing but the output does not depending on the previous inputs. But in sequential logic gate, the output is depending on the previous inputs also. That is order of the or sequence of the previous inputs. And second one is sequential logic gates in which the output is depending on the previous inputs. Now, one of the combination logic gate OR gate we will discuss today. Actually, OR gate contains only one output and two or more inputs. NOR gate is a combination of OR gate and AND gate. Not only that, by using this NOR gate, we can construct all basic logic gates, that is OR gate, AND gate, NOT gate, exclusive OR gates, etc. And not only that, one more logic gates we have, that is NAND gate. By using that also, we can construct basic logic gates, OR gate, AND gate, NOT gate, exclusive OR gate, etc. So that these two logic gates are called universal logic gates. Now, one of the universal logic gate, that is NOR gate, we will discuss now. NOR gate having what we said is that there is one output and two or more inputs, and it is a combination of NOT OR. It is nothing but the OR gate is followed by NOT gate. The principle behind this NOR gate is the output is 1 only when all the inputs are 0. It is nothing but if all the inputs are low, that is nothing but 0 position, and the output is high, that is 1 position. So if there is a 2 input AND gate where NOR gate, when we have taken, the output can be written as NOT OR. We know OR is nothing but plus, NOT is nothing but inverter. So that the output Y is equal to A plus B bar. A plus B shows the OR gate, where bar shows the NOT gate. So that Y is equal to A plus B bar is the Boolean statement for NOR gate. So the symbol of these NOR gate can be shown like this. This is the actually OR gate. The circle shows the NOR gate, NOT gate. So this is the NOT gate symbol. Now, the truth table of this NOR gate for two inputs, that is A and B, as shown in this figure. Two inputs is nothing but there is a 2 square, there is 4 combinations we have, because in all digital electronics, depending on the binary number system having only 2 digits, that is 0 and 1. So these combinations are 0, 0, 0, 1, 1, 0, and 1, 1. What is the output? We know A plus B bar is the output for the NOR gate, that is 0 plus 0 is 0, 0 inverter is 1. 0 plus 1 is 1, 1 inverter is 0, and 1 plus 0 is 1, 1 inverter is 0. 1 plus 1 is 1, 1 inverter is 0. So that if both the inputs are 0, then only the output is maximum. This is the principle behind the NOR gate. And of course, we can construct an OR gate by using different electrical circuits and also electronic equivalent circuit. The equivalent electrical circuit of NOR gate is shown this figure. Where in this case, we know in OR gate, there is 2 switches A, B are connected parallel each other, in which these 2 switches are connected and parallel to the bulb and battery. So this is equivalent circuit of the NOR gate. How can we explain? As shown in this figure, if A is 0 and B is 0, it is nothing but both inputs are 0. A is 0 and B is 0 is nothing but A is open and B is open. Then both of open is nothing but the current which is passing through the bulb. So bulb glows. That is output Y is equal to 1, because there is no current which is passing through the switch A or switch B. And the second case, if A is equal to 0, is nothing but A is closed. And B is 1, that is nothing but B is open. Then what happens? So if A is closed is nothing but the current which is passing through the bulb, which is passing through switches only by using short circuit. Because the switch is closed is nothing but there is no resistance. The resistance is approximately 0. But the bulb contains tungsten filament. It contains high resistance. We know their current always try to move through the zero resistance path. So there is high resistance at the bulb. There is no current which is passing to the bulb. Bulb does not glow. All current which is flow, which is through the switch A. So bulb does not glow is nothing but the output is 0. And the third case, if A is equal to 1, A is equal to 0, and B is 1. B is 1 is nothing but B is that is closed, and A is 0 is nothing but A is open. Then what happens? In such case, the current will flow through the switch B only. Because B is closed, there is no zero resistance path. Bulb having resistance, there is no current or maybe very less current which will pass through the bulb. So bulb does not glow, the output is 0. And the last one is A is equal to 1 and B is equal to 1. Is nothing but both switches are closed. In such cases, the all current will flow through the A and B. There is no current bulb passes through the bulb. So bulb does not glow, the output is 0. This is the functioning of the electrical equivalent circuit of NOR gate. Similarly, we can construct electronic equivalent circuit by using two transistors as shown in this figure. So this is a two NPN transistors we have. Two bases are connected with the two switches. This is a B and one switch, and A is another switch. And our two inputs are two variables. Those two collectors are connected to the plus VCC battery. Maybe it is 5 volt. The output is taken from the collector N. This where Y shows the output. Now, and two emitters are connected to the ground switch. So this is electronic equivalent circuit of NOR gate. How it will work? If A is equal to 0 and B is equal to 0 is nothing but two switches are there is no current which is passing through the two transistors. That is nothing but two transistors are in cutoff region. So A is equal to 0, B is equal to 0 is nothing but two transistors are in cutoff region. There is no current passes through the transistors. All current from the battery VCC passes through the output Y. So the output is 1. And the second case, if A is equal to 0, A is equal to 0 is nothing but transistor 1 is in cutoff region. B is equal to 0, 1 is nothing. B is equal to 1 is nothing but transistor 1, 2 is in active region. A is equal to 0 is nothing but transistor 1 is in cutoff region. B is equal to 1 is nothing but battery B base terminal is connected to the some volt, that is 5 volt. So that transistor 2 is in active region. The current will flow through the transistor 2. So that from current VC, the current will flow through this like this. So all current which is passing through the transistor 2, so the output is 0. So the output is 0. And the third case, if A is equal to 1 is nothing but if A is equal to 1 is nothing but it is connected to the 5 volt. So that the transistor T1 is in active region. And B is equal to 0 is nothing but a transistor 2 is in cutoff region. Now all the current will flow through the transistor to T1 through the battery VCC. So there is no output, so output is 0. And in the last case, if A is equal to 1 and B is equal to 1. If A is equal to 1 and B is equal to 1 is nothing but, in such case, two transistors in active region. So all current which is passing through the two transistors through battery VCC. So the output is again 0. So this is the functioning of the truth table of NOR gate. Thank you very much.